Dear Gemini PI, this is Emily Diebert talking to you from the Gemini Observatory. This short video will show you how to set up your observations with the Gemini High Resolution Optical Spectrograph, or GHOST, using the Observing Tool, or OT. If you're not already familiar with the OT or with the capabilities of GHOST, we recommend you visit our website and watch those videos first. To start, we're going to go through an example of a single target observed in standard resolution mode. Under the GHOST component, you can set your resolution mode, in this case, standard resolution, and set your target mode, in this case, a single target. GHOST has both a red camera detector and a blue camera detector. You can set separately the exposure time, the exposure count, the spectral and spatial binning, and the read mode for the two detectors. One key difference that you'll notice between GHOST and other instruments at Gemini is that you can increase your number of exposures by either increasing the exposure count here, or by increasing the number of observes, as for our other instruments. The main difference between increasing your number of exposures using the exposure count button compared to using the observe button is that everything defined within the GHOST component will be bundled together in a single FITS file that we cannot split during observations. For this reason, we recommend that you keep everything set up within the GHOST component relatively short and instead increase your number of observations by increasing the observe component. In this example, we're observing a source that needs more exposure time in the blue than in the red. We've set the blue exposure time to 300 seconds and the blue exposure count to 1, whereas in the red we've set the exposure time to 140 seconds and the exposure count to 2. If we had instead set only one exposure count in the red, all of this would be bundled together in a single FITS file. When the red exposure finished after 140 seconds, we would need to wait for the additional time for the blue to finish before the next red observation was taken. By setting up 2 exposures in the red and taking into account the readout times for the instrument, both the red camera and blue camera detectors will now finish observing at roughly the same time before moving on to the next in the observe sequence. You can work with your contact scientist to help optimize your time in this way. You can also choose various spectral and spatial binning modes, as you see here. Again, you can either read the website or work with your contact scientist to choose the option that will work best for you. We recommend that you keep the read modes to the standard modes, which is medium in the red and slow in the blue. If you think you might need a different read mode, please talk to your contact scientist. If we now go to the target component in GHOST and click on the image, you'll be able to see the target here. GHOST guides using the P2 wavefront sensor, and in this example, a suitable guide star has been automatically chosen by the observing tool. IFU1 for GHOST has a dedicated sky fiber, which you can see if you zoom in on your target. The dedicated sky fiber is marked by the blue here. The relative position of the dedicated sky fiber relative to IFU1 cannot be changed. However, if you find that you would like to move it, for example, if you find that the sky fiber is falling on your source, you can instead choose a position angle, which you set under the GHOST component. And now when we go to look back at our target, we'll see that the relative position of that sky fiber has shifted by 180 degrees. In general, we recommend that you keep the position angle to 0 unless you need to move it for a reason such as this. For GHOST observations, it's important to make sure you include a V-band magnitude for your target. For many targets, this will be found automatically by our system, but if it's not, you can modify it down here in the magnitude section. It's also important that you add in any proper motion for your target down here. Now let's look at an example of a standard resolution target plus sky observation. In this case, we choose the resolution mode to be standard, and we choose the target mode to be IFU1 on target and IFU2 on sky. Similarly, you could place IFU1 on the sky and IFU2 on the target. The observations in this example are set up in a similar way to the previous example. The difference is under the target component, where you'll see that IFU1 is on your target and IFU2 is now set to be on the sky. If you open the image, you'll see both IFU1 on your target and IFU2 on the sky. This is in addition to the dedicated sky fiber for IFU1, which you can still see if you zoom in. The position for the sky fiber, IFU2, will be automatically chosen when you set up your observations. But if you would like to change the position, you can do this in two ways. First, if you know the coordinates you want to use, you can type these in here. If you don't know the coordinates where you'd like to place the sky fiber, and would instead like to pick a position based on the image, you can do so by clicking on Drag on the left-hand side, and dragging the sky fiber to the location where you'd like to place it. The two IFUs must be at least 102 arcseconds apart, and they must lie within a circular area of 7.34 arc minutes as shown by this blue circle. Now let's look at an example of dual targets observed in standard resolution mode. Under the ghost component, we select standard resolution mode, and under the target mode, we select dual target. These observations are set up in the same way as the previous two examples. The difference is once again in the target component, where you can see that IFU1 is placed on one target and IFU2 is placed on the other target. If you open the image, you'll see the two IFUs placed on your two targets, located equidistant from the base position, which is marked in blue. If you decide that you want to observe a different target, for example, this target, if we look at the image again, you'll see that the IFUs are no longer centered, equidistant from the base position. To make sure they're automatically centered, we can make sure that link base to target is selected. And the two IFUs are now once again equidistant from the base position. Once again, the two IFUs must be at least 102 arcseconds apart, and they must lie within a circular area of 7.34 arc minutes, as defined by this blue circle. If you place the IFUs in positions that aren't suitable for the instruments, an error message will pop up in the OT. Now let's look at an example of a single target observed in high resolution mode. Under the ghost component, we set the resolution mode to be high. There's only one possible target mode, which is IFU1 on the target and IFU2 on the sky. In this example, we've set the blue exposure time to 1800 seconds, which is the maximum recommended exposure time for ghost. We've set the red exposure time to 540 seconds and increased the exposure counts in the red to 3. Under the target component, you'll see that the IFU1 is on your target and the second IFU is on the sky. You can open up the image and see that it looks very similar to the standard resolution target plus sky mode. We're now going to show you a few advanced cases and best practices for setting up your targets. This first example is an example of a case where our target does not have a suitable guide star. You can see here that the automatic guide star tool has not found a guide star that can work for these observations. However, there's a star slightly outside of the patrol field that might work well for the observations. In this case, we want to choose a new location for the base that allows us to reach that guide star. Unclick Link Base to Target and copy in the coordinates for a suitable base location that you've found. You can now see that when I've done that, an automatic guide star pops up. We can now reach the guide star. The base is slightly off-centered from our target. We're now going to look at a few best practices for setting up your observations. In some cases, a PI might want to observe a very bright target, and they might want to get a very high signal to noise. For very bright targets, you run the risk of saturating your observations. In this case, we might encourage the PI to reduce their exposure time and just increase the number of exposures instead. For example, in this case, the PI might instead choose to put only 100 seconds for their exposure time and increase the number of exposures. This avoids the risk of saturation. Another case you might encounter is that of long observations. In this example, in the ghost component, we have individual exposures of 1800 seconds and 8 exposures total in the observe component, leading to a total observation of more than 4 hours. In this case, we recommend that you split the observations up into shorter individual sequences. For example, a sequence of 1 hour, and copy and then paste until we have enough observations to cover everything that the PI requests. This will be easier for us to schedule and will increase the chances of getting the data. In cases where the observations cannot be split up, for example, a time-sensitive observation or a transit, you can leave them as is. If you have any further questions while setting up your ghost observations, we recommend you read through the web pages and contact your contact scientist or the Ghost Science mailing list.